Welcome everybody to a new video, part of the Fivefold Sun project, of which there are already 32 videos available on the internet as of the end of 2018. We are now in January 2019, and this video is dedicated especially to the Sun's internal structure, a beautiful, however invisible structure. And this video is for everybody, for the layman, for the children, for everybody. We are now at a time when science is turning its sights on the exploration of deep space, but perhaps we still have something to find in our own very close star, the Sun. Things that may be perhaps very significant for us and perhaps, hopefully, very understandable. This would be useful because the frontiers of science today challenge the understanding of the layman and even of the people of science. At the macrocosmic scale, relativistic rules and postulates of chaotic behavior make the understanding of the universe quite difficult for the common sense of the human people. At the macrocosmic scale, the other extreme of the natural world, as well, the quantic rules with their growing zoo of subatomic particles are hardly fathomable even for the learned specialist. So in between these extremes we have our own world, the solar system, and the star at the center of it, the Sun, which everybody knows. This is the solar disk as we can glimpse it every day. And we are going now to look into its structure and investigate quickly in only 17 cartoons what can be found in there. The Sun is basically a spherical ball, and it's closed, even though it is a free gas, by a sharp boundary called the photosphere. This is the line in this cartoon. The first fact that is clear with the structure of the Sun is that this ball rotates about a rotation axis with a north polar rotation pole and a south one. The second most obvious feature for the structure of this ball is that in the northern hemisphere, above an equatorial plane, the features that can be seen at the surface and can be inferred in the inside of the Sun are symmetrical with those in the opposite hemisphere, the southern hemisphere, and in the long term they mirror each other statistically. Now, if we go into more detail, I propose to you to go through an investigation in only about 14 cartoons, which will lead us from very simple observations to the inference of a specific and unique structure in this ball. We have to start from the fact that at the antipodal surface points that are near the rotation poles, the electromagnetic lines, which can be seen delineating the solar magnetic field during solar eclipses, are radial. At all other places, they are curved and close back to the Sun in the opposite hemisphere. So from this fact, we can now infer the intersection of the straight radial lines near the rotation poles and see where they intersect in each hemisphere. This can be performed when the solar bar magnet, its dipole inside the Sun along its axis, are at their maximum cyclical strength. The radial locations will define the poles of the electromagnetic field of the Sun, and it's called in the literature the equivalent magnetic poles of the Sun. The measurement of their positions has been performed since Campbell, a US astronomer who became the president of the University of California and of the National Academy of Sciences of the United States, suggested that they are at about 2/3 of the length of the solar radius. After observations after Campbell at various eclipses, it is found statistically that these points lie at a depth of 0.65 times the solar radius. Now we turn to another line of evidence to try to understand the internal large-scale electromagnetic structure of the Sun. And this is the size of the Sun's energy-generating core. It extends from the center to 0.31 times the solar radius, according to the numerous inferences performed from observations of the results of the fusion reactions, i.e., for instance, neutrinos, and from helioseismological measurements. It is also known, and this is a third line of evidence, that the Sun rotates differently in different shells. In the inner shell about the core, it rotates rigidly as a solid in this orange shell, up to a depth of 0.65 times the solar radius, which turns out to be approximately exactly the same as the depth of the location of the equivalent dipoles magnetic poles. So if we now go outside of the solid rotation shell, we land into a differential rotation zone, which starts from this depth to the surface of the Sun. What can we infer from combining these very simple facts? We can find that the depth of the more outward differential rotation shell, its width, is 0.35 times the radius of the Sun. As well, we can infer the width of the solid rotation shell, which has got to be here in between the core and the differential rotation shell, 0.34 times the solar radius. On each of the primary measurements, 0.31 and 0.65, we have an uncertainty, an error bar of plus or minus 0.01 times the solar radius, which will now allow us to adjust these different found depths. If we now assume that the depth defined as follows is exactly this, i.e. 0.655 times the solar radius, which is well within the error bars, then we have to have also this exact width for the inner shell, and both of the shells will have exactly with 3 significant digits the same width of 0.345 times the solar radius. This is the fundamental finding. And why is it important? Because it allows us to imagine an imaginary sphere having its center here at an equivalent pole of the solar magnetic field, and a radius which makes this sphere be tangential to the photosphere, the outer envelope of the Sun, and also to the solar core. So this allows us to have an outer ball of a radius of 0.345 times the radius of the Sun, which will fit exactly between the core and the photosphere, and which will be centered exactly at the boundary between the solid rotation and the differential rotation shells. This brings a new question which is very interesting, and I hope you will like this question. The question is, how many such spheres can fit in this shell of the Sun, and is this possibly an integral number? The answer to this geometrical puzzle is that 12 such spheres can exactly fit in this volume, and this is how it looks in a 2D projection in perspective. In this 2D projection on a sheet of paper, or if you will, on the plane of your screen, there are a core with its center at the center of the Sun, and 4 orange color balls which are in the same plane. Their centers are in the same plane, in the plane of your screen, as the center of the core. And we show, in addition of the 8 other such outer spheres which fit in the solar volume, only 4 for visibility, which are in different planes and which are shown in perspective. So you see, this is the beautiful structure, the invisible interior structure of the Sun, which is suggested in the results of my work, the Fivefold Sun project, and which we'll now show in 3 dimensions. 3 dimensions is necessary to show that this arrangement, which is according to the positions of the 12 vertices of a regular solid called the icosahedron, consists of 2 sets of 5 balls that are in a plane about the solar equator. And this is how this arrangement looks like. You see here the set of 12 balls, of which one is in a south polar position and another one is in the north polar position. And you see here a set of 3 balls, of which in total there are around the North Pole 5. And again here you see 2 in the front, of which there are again exactly 5 around the southern pole, as I will show now by rotating this contraption. You see the 5 balls, their centers are each in a plane which is parallel to the equator, defined by the 2 balls in the polar position. And if we shuffle the arrangement, we will have anyway always the possibility of aligning with the rotation axis a polar ball, and having always 5 balls which are in the same position with respect to this polar ball. Now, if we subtract the polar ball, we can see inside this arrangement, and we will see that there is a void at the center, which defines an imaginary cavity at the surface of which each of the 12 balls is tangential. So this represents, in the case of the Sun, the energy generating core, inasmuch as the exact radius defined by the icosahedral symmetry for the surface of this cavity corresponds to observational constraints on the size of the solar core. So this is the beautiful fivefold symmetrical icosahedral arrangement, which is consistent with the set of very simple large-scale observations of the Sun that was introduced in this video. We now turn to the kinematic over time of how this arrangement evolves during the solar cycle. You see the square of the number of outer balls, 12, is 144, and it happens to be the characteristic number of rotations of the core and of the solid body shell of the Sun over the 11-year solar cycle, the peak frequency of which, in fact, to be more precise, is exactly 10.61 years. Over this length of time, the ball performs exactly 144 solid rotations, and it happens to be the square of the number of balls that are involved in this rotation according to the suggested arrangement. So after such a set of 144 rotations, the north magnetic pole rotates into the position of the south magnetic pole. This is, of course, only an electromagnetic phenomenon, but it is as if the topology of the Sun was reversed vertically. After a second set of such 144 rotations, the solar magnetic pole returns in its initial position. After 144, i.e. a square number of the number of vertices, it rotates into the opposite antipodal position, and after the next one it comes back into its initial position. This is called the Hale full solar magnetic cycle, after George Ellery Hale, who discovered this principle in the early 20th century. This is simple. You got it as I got it. The next question is, because you never heard of it before, and in fact the community of solar physics has not yet been confronted with this finding, or let's say with this conjecture, we have to ask ourselves, is it really correct? Well, for now, we have seen a few lines of evidence, and if there is counter-evidence, of course, those who will find it will speak out. So far, the rest of the evidence is detailed in the book The Fivefold Sun, which I published in 2017. My name is Jean-Guillaume RICHARD, and I'm the author of this book. It is consists of 15 paper volumes and no less than about 6,000 pages, however, in only 6 electronic files, which I wrote over a span of 15 years and published in late 2017. And as I said, there are 32 online video lectures that sum up these findings. It is interesting to come back to the introduction to this video about the state of the art of space science. It is interesting to compare with other stellar entities. Such entities which are closest to the Sun in their nature are the so-called solar analog stars, which have similar physical parameters. There is only 24 of them that are known. And it turns out that they also, their bulk rotation seems to average out to 144 rotations over their activity cycle, as is found here for the Sun. Also, the same basic structure, icosahedral symmetry about a core, seems to exist in the atom. A video will follow with evidence of this assertion, which I did not find. It was found and published many decades ago by atomic scientists, and it is also found in numerous macromolecules. So the Sun seems to abide by the rule of icosahedral fivefold symmetry in space and also in time, as shows the decomposition of its solar cycle. It is far from being a chaotic behavior or chaotic entity, as is, however, presumed by many contemporary theorists. And the finding that is proposed today and is understandable to all is what was expected by the 19th century British observer Carrington, who said that it is not realistic to expect that the Sun is ruled by caprice. In fact, it seems that the Sun is structured by a universal principle of the beautiful fivefold symmetry, both in space and in time. And you understand what I just proposed, because I have not any superior training compared to yours in the matters that were discussed today. I am a science high school dropout, and yet I was able to submit and obtain publication from the reference peer-reviewed International Journal for Solar Science on 2 occasions. So please, in your own themes of research and personal investigation, feel free to think by yourself and propose new ideas, and give also the fivefold Sun a chance. Thank you for your attention.